Not all 5G is made the same. So there's a speed, there's a bandwidth thing, and then there's coverage. How many people get to enjoy today, and how does the progress in the next 5, 10, 20, 30, 50 years you think looks like in terms of coverage?
Great topic of conversation. So let's talk about this. When I meet with regulators across the globe, I tell them resistance is futile.
Yeah.
Allocate every spectrum to wireless. Every spectrum needs to be allocated to wireless. The reality is when we start moving from CDMA to OFDMA, we knew that this industry has done a lot to get more bits per hertz. But the reality is the massive amount of improvements that is required in capacity and in speed, you need more spectrum. There's not so much we can rely on more bits per hertz. You just need more spectrum. And if you look, for example, what carriers, since the 2G era, they participate in different license and auctions, and every spectrum they accumulated from 2G or 3G or 4G, all of that, you may be able to get 1 or 2 channels max of sub-6, which is a channel is about 100 megahertz or 200 megahertz, and that's it. So we need more spectrum. So 5G has been designed to work across every spectrum, from the low frequency bands, that's what we call the sub-6, but you needed more. You needed to go to the millimeter wave. So that's why 5G is a technology that you can deploy from 450 megahertz as an example, or 600 or 700, all the way to in the 42 gigahertz. And that's where millimeter wave comes into the picture. Now, let's now connect this to your question about coverage of 5G. The easiest thing to do is to deploy 5G in the new spectrum you can get, which is in the sub-6. You see bands being auctioned across the globe in the 3.5 gigahertz. There's nothing special about the band. It's just the only one that was available because everything else being used for 4G. And you can deploy on that, go into existing cell towers and just put a new equipment without having to build new towers. But when we go to technologies such as millimeter wave, then you have to build more dense networks. You need to build more stations because a deployment in that case look like a Wi-Fi deployment. It's almost like Wi-Fi access points. When you need to build more stations, you need permits. You need to build fiber, so it takes more time to densify. So what you see happening is coverage is being built fast with sub-6 across the globe. Now, the United States also have the sub-6. So that gets you to coverage very fast. But millimeter wave, it's moving. And I will say, for example, Verizon, United States has had a leadership in building millimeter wave. It takes time. I'll say cities like Chicago, Manhattan, starting to get coverage. It will be a process over a number of years as you build those different access point type networks, but it's inevitable. There's not enough spectrum. So every 5G operator, it's just a matter of time, will have millimeter wave as well.
Resistance is futile. Okay, so for millimeter wave, we need density of access points. And what's the biggest resistance for Qualcomm, for human civilization? Is it politicians, regulators, federal regulators? Is it individual humans? Is it not enough money from the consumer perspective? Like, who is the biggest pain in the butt?
From a Qualcomm standpoint, but answering the question about what it takes to build all this technology.
Yes.
I think regulators across the board understood the importance of 5G. I have not met a regulator that said it's really important to be late on 5G. I don't think anybody wants to be late on 5G. And as a result, we've seen enormous amount of progress in getting spectrum allocated to 5G. I think the real issue is the time that it takes to build infrastructure. Investment in 5G infrastructure, especially millimeter wave, is like building roads and ports. It's critical infrastructure. And those things take time. Like one of the number one obstacle you're going to hear from operators is site permit. sometimes they have to negotiate municipality by municipality about permits to get new cell sites. But the networks will be densified, and you're going to need all of the capacity for the promise of the fully immersive augmented reality that will replace phones and everything being connected 100% of the time.